bulb. Okay, I'm going to be uber paranoid as usual. Got an isolation transformer and a 150 watt bulb in series with the line cord. Let's see what happens. Alright, bulb is lit up. Bulb is dimming down. Tube filaments are glowing. Channel pilot light is glowing. Alright, so obviously no dead shorts. I've got the filaments wired up correctly, so the tubes are lighting up. I'm starving a set of juice, of course, with that bulb, so... Oh, we've got sound, and it's... Oh, not sound, I mean, we've got static, and it's responding to the volume control, so that's good. And no picture. But that could very well be because I don't, or because of the light bulb in series, sorry. Mumbling as I'm fiddling with controls. Alright, so I'll let this run for a little while and then take that bulb out of the set. Okay, here we go. Full power up test. I've got my DC voltmeter on the 275 volt bus so we can monitor that. So we get that on, and here comes the set on. A bit over 300. I hope that drops as the set warms up. There it goes. That's a good sign. Hopefully we'll get some high voltage this time. Huh, still no vertical. Full horizontal though. I'm surprised the vertical output transformer did test okay, but I did not check the yoke. So that could be bad, although I hope my YouTube friend that had one of these sets saved the yoke. He did save some parts. Let's see if we can get some sound at least. Try hooking up an antenna. A little surprised there's no sound because we did have some static hiss before. Well, I checked the resistance on the vertical yoke and it measures exactly what it's supposed to, so that's a good sign. So we've got a couple major problems. I'd like to fix the vertical first to see if I get an image, because if I have an image and I know the tuner is working alright and I can isolate the problem to the audio circuitry. But if there's no sound and no picture, then the problem's likely to be in the tuner or the IF strip. Now, I do have some waveforms here and there throughout the schematic, so I can start checking on the vertical signals, in particular these guys here. Now, if you recall, I left the original vertical integrator hybrid module in place. That could very well be a culprit. So what I can do is check for the sync signal here, and if I got an okay signal on that side but not on the other, and then it's likely to be a problem. Now one thing I can also do is I can inject this signal, I think using my B&K 1077B television analyst, because it does have vertical grid drive, although I've never tried using it, but I can certainly fire it up, put it on my scope, and see if I can generate a signal of the correct shape and amplitude, and then feed it in here. So I guess that would be that signal right there, which is the grid on the vertical output tube. I think I may have found the problem with the vertical. These two tubes here form the vertical multi-vibrator. It's an oscillator, and that's what drives the yoke, and the sync signal vertical integrator signal coming through here is what keeps this locked into the received signal. Well, when I was working on this circuitry, I encountered this capacitor, which is a 1000-volt capacitor. I did not have one on hand, so I had to order one, and I was able to find one at Mauser Electronics, and it was actually rated for 1200 volts. Just one problem. It's still here in the bag. I never got around to installing it, because while I was waiting for this order to arrive, I moved onto this board and completely forgot I needed to install it. And, of course, the board's back mounted in the set now, so not so easy to get to. Fortunately, though, I think I can do it from the top side of the board. I'm trying to remember where it goes. I think it's right in here. I think this stub here is one lead of the old capacitor and the other lead goes over here, and there's a tie point so I can solder onto that. Yeah, that would make sense because that's the vertical plate there. So one side goes here and the other side I can wrap around this remaining tail of the old capacitor. Alright, there it is. Let's see if that made any difference. Wow. We had sound for a moment, and we have a full raster. Alright, progress. Curious that we had sound for a while, and I also recall I had some snow that I could vary with the volume when I had the light bulb in series. In other words, when the set was running on reduced voltage, it seemed to be running better with some regards. So let's see, turn the variac down easily enough. It's funny, even with the variac down to 100 volts, we still have a raster I can see. Also, I can see that the channel indicator is a neon bulb, because when you drop it down, it goes out. I think they need about 90 volts or more to run properly. Alright, well, I can't get the sound to come back, but... Alright, raster's good. Also, now can see that we don't have sound and no picture. So the problem does lie somewhere in the tuner or IF stages. In fact, you can see the tuner makes no difference. Even though there's no channels on most of these, only channel 6, you should still get snow with varying patterns as you change the channels, and I am not. I'm doing some basic voltage checking on the IF board, and things are looking more or less okay. Like this point over here should be 165, and I've got 171, which isn't too bad. And on the 275 volt bus, I got 270, and I got to this point. Now it's a little confusing because it says 150 on the PCB, but it's definitely 190 volts on the schematic. They also show 190V here, so it's that point right there. 2 resistors going to it, and then a wire goes around to the flip side to where the filter caps are. Now, what do I have there? About 271, in other words, that's the same as the main bus. So I'm guessing on the other side of this, which I can't get at now, there's a wiring error. I'll have to take the set apart again to see that. Here's a little look at the schematic, show you what I'm talking about. So there is the main power supply. There's the main bus, right? There's the highest voltage potential, 275. Then there's some power resistors for various taps. And we should be down here, a 190 source. So there's supposed to be a 3.5K 5-watt resistor in between that 275 point and this point. So there's only two possible ways I can think of that we've got almost that full voltage there, 275, and that is this resistor's fried. I've got a wiring short somewhere, so it's effectively taking that resistor out of the circuit, or there's very, very little current draw, which would mean there's virtually no voltage drop across the resistor. Now that 190 volt source powers a few things. There's the two resistors we just saw on the IF board, the 22K 1 watt and the 330 ohm. And it also goes to the tuner. Over here. But that's kind of vague as to what it actually connects to. So I'm not quite sure. The current draw is a little puzzling, because if I check, for example, this 1 watt power resistor on one side, 270.5. On the other side, almost 270. Which means there's very little current going through this. And likewise on this little resistor down here, very little voltage drop. So it could be everything's actually fine on the other side, and the problem is that there's not enough current being drawn on this board. So I'm going to do a little more poking around on this before I take the set apart, because in order to check what that wire is going to, I have to take this whole thing apart again. I powered down this set and hooked up an ohm meter between the 275 volt bus and what is supposed to be the 190 volt bus, and I've got about 3.4K, which is pretty close to the 3500 on the schematic. So I don't think I made a wiring mistake and directly shorted the 190 to the 275 bus. So where does that leave us? Well, there's something else I did. Is I pulled out this tube, which is what goes to these two resistors here in that 190 volt bus, and I put in one of these extender sockets, which exposes all the pins, and I checked the voltage. And I happen to show on the schematic what all those voltages should be. And instead of 140, instead of 165, I got about the full 270. In other words, like I was saying, there's just no current being drawn, so that label 6 point there to the 7 and 8 pins on the tube, it's just not drawing any current through those resistors, so it's not pulling down the voltage. So what would cause that? Well, the tube could be bad, or the tube could be biased incorrectly. So I checked pin 2 there, which I believe is the grid, should be minus 0.5 volts. I found minus 46 volts. Which is so negative it's going to cut off the tube and it's not drawing any current. So what's that going to? Well, if you go through these, there's a low ohm inductor here, only 0.1 ohms, and you keep going and you keep going. That goes to the tuner, which is this coax here. And there, yes, I have minus 46 volts. So where's that going? Up into here, which is not the easiest thing to get at. But I'm going to have to attempt, I guess, to check some voltages on here. So on the SAMs here, I do have the full schematic for the tuner. And that RFB plus, that's supposed to be 190 volts. And there's the IF output. Ah, see, there's a couple different versions of this, so I'm getting confused. Okay, so the UHF provisions, I probably have this version. Now, what I'm finding odd is for the IF output, they just show a capacitor, meaning there's no DC voltage. So if that's the case, that minus 46 volts is not coming from the tuner. It can't be, because we only got AC coming from the tuner. So what would develop a huge negative bias in here? I'm going to have to do some poking around. The voltages on the tuner seem to check out okay, so I then moved on to doing some resistance measurements. The service info includes this handy chart, which shows what the resistance between each 2-pin and ground should be. What you do is you turn off the set, pop a tube out, hook up your ohm meter between ground, and then check each 2-pin. So for example, on pin 1 of V1, you should get 27 ohms. And I got very close to all these values on all the tubes I checked. Alright, well, I then moved back to doing some more voltage measurements. This time on the key AGC tube. Because that bus off the plate there goes through a resistor or two and eventually goes to the grid on that tube where I was measuring something like minus 45 volts, where it should be minus 0.5 volts. So, what do I get when I check pin 3 there? Well, let's see. By the way, if you're going to work on sets that have circuit boards mounted like this, I highly recommend you invest in a set of these extender sockets. They can be expensive, but without these, very difficult to check tube pin voltages. Alright, so here's pin 3. And we have minus 133 volts, which certainly is not plus 95 volts. Also notice that the overload ring on my meter is flickering red. Well, it can certainly handle way more than that DC voltage, so it's probably an AC component to it. So if I flip my meter over to AC, put that probe on pin 3 again, and my meter freaks out, meaning I'm overloading it. There's got to be some pretty serious voltage spikes on that tube. Alright, so where could that be coming from? Yep. Trace that wire around and around and around and around. It goes over the flyback, which of course creates lots of nasty voltage spikes. So I believe the way this is supposed to be working is the keyed AGC action requires a pulse off the flyback as part of the way it works. That's where the key part comes from. I believe it's keyed to pulses from the flyback. So I suspect something right in here is not right, which could very well be this capacitor. 120 picofarad 5000 volt cap. Take a peek under here. It's mounted on the flyback frame. Up in there. So not the easiest thing to get at. So how can I test that theory? Well, if the tube used a power transformer and had parallel wire tube filaments, I would just pop the horizontal output tube out. But I can't do that in this case because then the set won't work. But what I can do is simply pop off this plate cap. Oh, the tube is hot. That plate cap goes right here, and that goes to the flyback. With that out of the circuit, no power going to the flyback, won't be any pulses generated in here. Of course, there won't be any high voltage, we won't have a picture, but maybe we'll get some sound. So, let's see what effect that had. Let's see, make sure this is on channel 6. Yeah, it's on channel 6. How about that? We have sound. Now my stomach is sick, and it's all on my head, but it's changed now. You take some rest now. Let me go. The greatest sound ever. We have an antenna hooked up. Alright, so I need to do some more investigating. Unfortunately, they don't really show much, they don't show any scope signal in here about what the signal should look like anywhere in this whole area here. So I guess I'll just have to double check the wiring and try to test that capacitor. Now all these components in here are mounted on the other side of this metal box, which means I have to take the set apart, so I think it's just unavoidable. I'm going to have to unmount the picture tube and so on to get at those components.